Today I'd like to look at a couple examples with the student's t-distribution, one confidence interval question and one hypothesis test question. So number one says, suppose that an archaeologist discovers only 7 fossil skeletons from a previously unknown species of miniature horse. The shoulder heights in centimeters of the 7 skeletons are listed here, and we want to find a 99% confidence interval for the shoulder heights of the entire population of horses. So let's go through all the steps, starting with the givens that I usually like to write down perhaps on the left side. So we've got some data here, and I'm going to type this into my calculator, but I can see, of course, looking at this, that I've got n equals 7. And let's go ahead and grab the calculator and type these data points into it. So we got 45.3, 47.1, 44.2, 46.8, 46.5, 45.5, and 47.6. Then I can do the 1var stats, stat calc 1var stats, to find out this bit of information right here. You can check with your neighbor to verify, or you can see, of course, what I've got. And we get that X bar is 0.143. We've got S is 1.190. N, of course, is 7. I'm looking for a 99% confidence interval, and if my N is 7, then the degrees of freedom are going to be 6. Next, let's go through the conditions that are necessary. Well, I notice that I only have 7 fossils. So I hope that these 7 fossils are like an SRS. I don't necessarily know that's the case, but all I found are 7 fossil skeletons, so I don't really have many options as far as this is concerned. I'm sure there were more than 7 times 10 equals 70 of this species of horse. Now I'm a little bit concerned about the shape, because I see that I have a small sample size. I know I don't know sigma, but I need to look at the shape to see if with this small sample size that it's reasonable to consider this to be from a pseudo-normal population. So I'm going to look at my data. You can make a box plot to see if there's outliers, but to find normality, I probably want to look at either a histogram or a normal probability plot. So looking at a histogram, I get this graph, and I could say this: while the graph of the data is clearly non-normal itself, and then I'm going to draw a little sketch of it so that somebody can see for themselves what I'm talking about. And all I really care about here is the shape, so I'm not overly concerned that you label it or do anything else. Since it's clearly non-normal itself, while the graph of the data is clearly non-normal itself, I do see reasonable symmetry and no outliers, which is good for a small sample size. So based on all these things that I just said, I will use the T procedures. Therefore, I will use the T procedures. So now let's do a little bit of work. I know the formula is x bar plus or minus the t star critical value times s over the square root of n. X bar we knew was 46.143. I'll come back to the t star. S was 1.190 and n was 7. Now to find the t star critical value, I'm going to look on my green chart. And so from the green chart, or from the t table, I will go to the row that has 6 degrees of freedom, right here, 6 degrees of freedom, and make this a little bigger for you. 6 degrees of freedom, and then I need to find where that intersects with 99% confidence. So 99% confidence, 6 degrees of freedom, gives me a t-star critical value of 3.707. So this value right here will be 3.707. Now you can finish this out the long way, or you could grab your calculator and go stat test t interval. You've got the data in L1. We're going to change this to a 99% confidence interval or confidence level. And when I calculate, it gives me what this would work out to be, 44.475 to 47.81. And writing a conclusion in context, I am 99% confident the true average height or shoulder height of this species of miniature horse is between 44.475 centimeters and 47.81 centimeters. And that's how you'd work the confidence interval with a single sample. So now continuing to part number 2, it says, suppose that an existing species of miniature horse is known to have a mean shoulder height of 48.5 centimeters. Is it reasonable to believe that the newly discovered fossils are from a shorter species than this? Now the first thing to note is I will use the same conditions as above. The conditions for the confidence interval and the hypothesis test are no different. And so now I'll set up the problem. HO, mu is 48.5. HA, mu is less than 48.5. And I need to define my mu because this is a big deal. There's 2 different species of horse. The mu I'm talking about here, mu is the average shoulder height of the new species. In centimeters. And it's the new species because I know that the existing species is 48.5. So you could say the new species or the fossils, the species that the fossils contain. When I draw me a picture, I've got the t distribution with 6 degrees of freedom. This is 48.5. The x bar that we have was 46.143. This area right here will be the p-value. My standard deviation is 1.190 over the square root of 7. So I want to know what's the probability my x bar is less than or equal to 46.143. When I standardize it, that x bar becomes a t, and it's x bar minus mu over s divided by the square root of n. And again, we could do this in the calculator or the long way. For right now, I'll use my calculator. And so I would go stat test t-test. Again, the data is already in there, but my new mu naught is 48.5. The data is in L1. I'm doing the one-sided less than test, and I calculate a t-test statistic of negative 5.24, and I would get the p-value of a very small number here. If you were using your chart, once you calculated this out to get the negative 5.24, you'd look on the chart again for 6 degrees of freedom, and you see that 5.24 is between these two numbers here, which means that my p-value is between these two numbers here. And so if you were doing that, you could actually write that your p-value was between let's see what it was again, 0.0005 and 001. And you could write that either way, because either way, with such a small p-value, and let's just use an alpha of 5%. If alpha is 0.05, since my p-value is less than alpha, I will reject HO in favor of HA. I no longer believe the average height of the new species to be 48.5 centimeters, but in fact something less. And that's how you do the small sample hypothesis test. Next time I'll do the other side of this page, which includes a two sample t procedure.